Now we're going to get started working with discrete probability distributions. This section has got some terminology that we've used before that we're going to review over, and also some new terminology as well. So, first of all, terminology, a random variable. A random variable is designated by the value x. So anything that we're interested in looking at, if we're looking at height, if we're looking at weight, if we're looking at miles people have driven to a class, if we're looking at for wildlife distributions as they're migrating, whatever these things are, we would designate them in a numerical problem as an x. It's a random variable if it has a single numeric value that is determined by chance for each outcome of a procedure. Now the key terminology is here is single numeric value. So let's go through and apply this just a little bit to some sample problems to make sure that we're all on the same page with this. So going through and specifying whether each of the following examples is a random variable. Pause the video here for a few moments and go through and just jot your answers down into your notebooks, and then once you've completed that, turn the video back on and we will proceed and check it together. So if we were looking at these, how many students, for example, would be sitting in a classroom today would be a random variable. It has a single numeric value. The gender of students in the class today would not be a random variable. That would be something that we'd be designating by a category. So if you remember when we would look back earlier in the semester, we were looking at the different levels of measurement that we had. Okay, so when we're looking at gender, that would be a categorical type of measurement, thus not a random variable, does not have a numeric value. How many miles students drove to attend class today would be a random variable, that's a single numeric value, whereas the color of those students' cars would not be a single numeric value. So keep in mind in problems we can assign a numeral to designate a particular category in data. So if you're working with an Excel file or SPSS, of course you can't type in red, blue, yellow, green, etc. for the color of a student's cars. We would be able to go through and set those as to be having a number such as 1 indicates the student's car was red, blue indicates the student's car, 2 indicates the student's car was blue, and etc. But those numbers, 1, 2, 3, 4, are designations representing a category. They are not themselves an actual measurement or count. Okay, so that's the important distinction to pay attention to there. Now, let's take a look at discrete random variables and continuous. So a discrete random variable is a collection of values that's finite and it is countable, whereas a continuous random variable is a collection of values that is infinite. It has an infinite possible number of values and is impossible to count the individuals because at least some of them are on a continuous scale. It is measurable. We looked at this before previously in this semester. We paid attention to whether or not something was countable. So if you can count it, it's a discrete random variable. If you have to measure it, it is a continuous random variable. So again, let's go through and apply this to our questions here on the right and go through and again pause the video and go through and add into your notes just real quickly. Which of these would be a discrete random variable and which ones would be a continuous random variable? Once you've got your answers in your notes, turn the video back on and proceed to the next slide. Okay, so if we're applying these criteria, we can see that how many students are in class today would be countable because sit there and count the number of students in a class. How many miles students drove to attend class today would be something we would have to measure. We would measure it, for example, in miles or meters. Okay, so that's a measured amount. Similarly, the heights of students is a thing that we would have to measure. So it is a continuous random variable. And lastly, how many questions were on exam 1 is something that is countable. So this is something that would be a discrete random variable. Another way to help you keep track of this is to be noticing that if a particular value is followed by some indication of units, so whether it's pounds, meters, if we're looking at Fahrenheit, Celsius, any of these things, if you have to have a amount of units after it to give it meaning, then you're probably talking about a continuous random variable because you're measuring it. Okay, if you have problems with some of these, you need to check them and get a little bit more practice with it. Problem number 5 in the back of this section has a whole set of different examples that you can go through and answer on your own. And again, of course, you can check the answers for the odd numbers in the back of the book. So if you feel like you want a little bit more practice on that before you start the homeworks, that's a good place to gain it. All right, so let's go through and do this. We're going to use problem number 6 from page 207. So the answer, this is an even one, so you won't find the answers in the back of the book. So we're going to go through and do this together. And then, as I said before, if you want to, you can go back and do number 5 on your own. So pause the video here. Let's go through and put down into your notes whether or not these are a discrete random variable, a continuous random variable, or not a random variable at all. So pause the video, go through and do these options, and then turn the video back on and let's check your answers together. Okay, so A is not a random variable. Eye colors of humans on a commercial flight is not a category. Again, I mean, is a category, not a measurement. Okay, so the weights of the humans on the commercial aircraft flight, now that would be continuous because we would be weighing those and we'd be reporting them in pounds or some other type of weight. Numbers of passengers on the commercial flight, that would be discrete because again we can go through and we can count them. Political party affiliations of adults in the United States, that's not a random variable, that's a category. And the exact cost of presidential campaigns, that we can go through and that's discrete because we can go through and count that as an exact amount. Okay? So hopefully this will help you get familiar with the terminology that we'll be using for the rest of this section. If you have any questions, go through and do the practice problems number 5 and check your answers there. And this should wrap this one up, and we'll be moving on into the next lecture, which is we're going to be looking at the criteria then for doing a discrete probability distribution.